All right, so we're on chapter 3 on determining change, derivatives. Now this is section 3.6 on rates of change of product functions. So models can be structured as a product function, but they don't have to actually start as separate models. So we can actually have all built into one already. We don't have to have the separate models. Now, what we have to do then is we have to look at the model and separate the factors out. And so we have an idea of what the two products are, and then basically what the two functions that were multiplied together to give the original function. Okay, and then we can use our product rule for derivatives that we've been using, and it can be applied to those two products. Okay, so we're going to see something that'll give us a single function. We have to break it into two functions of products, and then we can use our product rule from there. And so, a good example is this one where we have f of x equals a times x times e to the negative bx, where a and b are constants. And this is kind of referred to as a surge function. So what happens is it shows a rapid increase to a maximum followed by almost exponential decay. And then these surge functions are used in medicine, physics, environmental studies, business, and economics. So they're useful in other things, not just business. We can get it in all these other different sciences. Now, products with composition. So not all product functions are made up just simple components, as in the surge function above. Your a and x and e to the bx, b to the a x e to the negative bx. Sometimes there's going to be some kind of a composite function in there that we're going to have an inside function and an outside function, and we're going to have to do derivatives that way. So it's not just going to be a simple, easy thing. We're going to have to look at it and kind of work our way through these. Now, quotient functions are functions that are basically quotients, and then we can treat them as a product using a chain rule. So we've kind of been doing that. If we had this, we would write g of x times h of x to the negative 1, because that would take it to up here, make it at 1, and then we can use the product rule. Or we can use the quotient rule. Now notice in the book, the quotient rule forgot to put in the prime here. So if you're doing this, be sure to have your prime in there because the book is not correct on that. And so what it is taking g prime of x times x, h of x minus g of x times h prime of x, all divided by h of x squared. So we just take those, find the derivatives, and plug them in the appropriate place, square it in the appropriate place, and we got our derivative. So we'll do one example of that, but since we're so used to doing the product rule, I'm going to do the majority or all but one as the product rule instead. All right, so let's start here. It says find the derivative formula for the following. All right, and here we're given the function, and what we have to do is we have to think about this. What are the two functions that could have been made or used to make that product? Well, we could have said, well, one of them is going to be g of x, one of them is going to be h of x, doesn't really matter. And I'm just going to use the first one is ln x, and the second one is e to the x. So now g prime of x is what? Well, that's just going to be 1 over x. H prime of x is equal to e to the x. Now I can find f prime of x, because now I know I'm just going to take my g prime of x times h of x plus the g of x times h prime of x. So 1 over x times e to the x plus, and now I have ln x times e to the x. Now, can I simplify it? Yeah, I can take e to the x over x and then plus ln x dot ex, or I can even put that in parentheses if I want. Okay, and so that would be my final, f prime of x. And again, what we had to do is we had to figure out what two functions we had to multiply together, separate them, and then do our derivatives, and then use our product rule, and we have our final derivative. So this one, I have, again, two functions. I can say my g of x is equal to 3x squared plus 15x plus 7, and my h of x is equal to 32x cubed plus 49. Now these are simple. We can find those easily without having to do too much work. We'll just take 2 times 3 and get 6 times x, then plus 15, and that's our derivative of this one. Now, what's the derivative of this? Well, we're going to take 3 times that, so that's going to be 96x squared, and that's it. Okay, so now we can say, well, f prime of x is equal to what? Well, it's going to be equal to 6x plus 15 times 32x cubed plus 49 plus, and then I'll have 3x squared plus 15x plus 7 times, and then I'll have 96x squared. Okay, and you could, distribute, multiply, and then add everything together, but there's no reason. We'll just leave it into our format here. That way we know which ones are the g primes, the h primes, the g f's, and g's, so we don't have to take it any further here. So that would be where I would stop. All right, I'll stop there and then I'll come back with more.